Hello there, it's your friend Phil, project management trainer and coach. Today we got a question in from Cheaton, and Cheaton asks, can you please explain the control charts technique with an example? So control charts are used by managers, quality managers or project managers to ensure that a process is in control, and as they do that, they're also determining if the process is out of control. So it's quite an extensive topic, but I will give you the top of the waves regarding control charts. Now, suppose you're in a factory manufacturing an electrical widget, let's say 12.5 in terms of length, 12.5 inches. But instead of it being 12.5, okay, so you got all these measurements across the board. We got about 11. Let's make it 12. 12.6. Okay, so you got various measurements across the board, and all of these are widgets that were produced during a particular time period. And these time periods could be 115, 120, 125, 130, like that, over a period of time, right? So with all of these measurements, we can find what the mean is. And from determining the mean of these measurements, we can then go a step further to determine something that's used in control charts. It's a feature used in control charts. Let me just very quickly remind you of what is used in these control charts. So if you would recall, in control charts, you have a line in the middle like that, which we would call the mean. That would be like your mean. But in addition to the mean, you also have a lower line known as the lower control limit. And you have an upper line known as the upper control limit. And the idea is, if you plot these points over time, so that axis also represents time as you go in that direction. So you have something that was done at 12:50, 12:55, 1 o'clock, 1:05, 1:10, you know, like that. You have various points scattered all over. Okay. The aim of the control chart is to help you understand if these points are in or out of control in a particular process. That is the summary of it. And then when they're joined by a line, it's called a run chart. Okay, but these aren't given in the PMBOK guide. So my guess is, if we read the PMBOK definition of some of this stuff, it will be pretty cut and dry. It's not going into as much detail as it used to once upon a time. Once upon a time, there used to be a more elaborate discussion about control charts in the PMBOK guide, but not anymore. So let's go to where these control charts are mentioned. And I believe you'll find these in, if nowhere else, yeah, you definitely find it in control quality for sure. It's under data representation. And the reason, of course, is because all of this data that you've gleaned from your process, you've now represented it in a control chart, you see. So let's read on page 304. It says control charts are used to determine whether or not a process is stable or has a predictable performance. And I mean, from a control chart, you can tell. For example, if you got lots of points above the upper control limit, it obviously tells you this is out of control. You see, this is out of control. Or if you have 7 non-random consecutive data points like this, to one side of the mean, 2, 3, 4, 5, 6, 7, something like this, even though I haven't drawn them as consecutively as I would have liked. A process with this feature of 7 non-random data points bunched together above or below the mean, we call this out of control, out of control. This process is out of control. We also call this situation here an assignable cause, meaning we need to assign a cause to why this happened. We also would call this one here out of control and an assignable cause too. Anything outside of the UCL. And watch this. Some quality managers will go after points that are so far removed and seem non-random, like this would be a weird occurrence to some quality managers that they may want to look into. But if you're going with the definition of what the out of control clause represents, it's a non-random data point outside of the control limit. It's also 7 non-random consecutive data points above or below the mean. So, above or below, and I know I'm not drawing these sequentially, but let's say these were 7:55, 8 o'clock, 8:05, the next 7 in that line, and you had something to this effect, this would be a concern, you see? So the way it would look if things were in control would be a bit different. You wouldn't have these 7 consecutive points like that. You would have something more like this, like that. Point here, point there, maybe a couple of points here and there, but you can see this is moving forward in time. And it's important that as you go in that direction, you're thinking about moving along in time. So you're seeing the progress, and then boom, something happens here, oh, this is 9:55. That's when we had the fire alarm, and therefore there was no one taking note of what was happening in the production lot or production facility. You see, so a control chart also tells you a picture, paints a picture, tells you a story about what happened and when, okay? So if we go back to reading what's on page 304, it says upper and lower specification limits are based on the requirements and reflect the maximum and minimum values allowed. Upper and lower control limits are different from specification limits. The control limits are determined using standard statistical calculations and principles to ultimately establish the natural capacity for a stable process. The project manager and appropriate stakeholders may use the statistically calculated control limits to identify the points at which corrective action will be taken. So applying a formula, we can determine what the UCL is and what the LCL is. And based on that statistical analysis, the points that fall outside, we're going to take action to correct the process, to correct those defects, to weed out any defects that we found that do not conform to the control we're trying to implement, you see. So this tells us if we need to do something about our process or not. It says to identify the points at which corrective action will be taken to prevent performance that remains outside the control limits. We don't want this to continue, you see. Even this, though inside, it would give a quality manager some concern, But let's be a bit more liberal here and say, let's just deal with those that fall outside the control limits. Because we could take this further. There's a lot of specifications about, well, if 3 or 4 points are of this nature, then we could look at the process as being something, but that is outside the scope of the PMP exam. Ultimately, you just understand what it means. What it's really trying to say is that these points are out of control if they fall outside of the UCL. They're out of control if they fall outside of the LCL. And if you've got 7 non-random consecutive data points, if you've got 7 non-random consecutive data points above or below the mean, like that, then there's a problem. All right. So with that said, I hope you understand, Cheaton, the overall idea now of control charts. Let's go back to what I was showing you a few seconds ago in Excel, and let's continue talking about that. So here we are with the measurements that we're taking of that particular widget that should have been 12.5. What we're going to do now is we're going to first of all find the mean. Okay, we're going to find the mean of this particular, let's call this a sample of the population, all right? So we're going to find the mean, and we're going to put the mean right down the middle for all of them, but let's put the mean up here first of all. And the mean of this arrangement, average of these. Oh, there we go. Had to double click enter. There we go. All right. So the average is 12.141666, whatever it is. So let's round that. Okay. And let's just copy that equals to this. So I'll just copy it and paste it as a value. Okay. So that's the mean. The next step is to find the upper control limit and to find the lower control limit. So we've got the UCL and we've got the LCL. So at this point, let's take a look at how to get our UCL and LCL. I'm going to insert one more line here, and we will go into the formulas again. Hopefully I can find where that stuff is. Standard deviation. And Excel has a formula. So if we do equals standard deviation, got standard deviation for the entire population, but we're considering this is part of a sample. So let's go with that. Yep. And let me close the bracket, hit enter. And that is my standard deviation. Okay. What is the standard deviation really? The standard deviation is the average distance of each of these values from the mean. It gets rather convoluted after a while, but just think of it like it's the average distance of each of these measurements, 12.5, 12, 11, 11.9. If you really wanted to calculate this, it's a bit of a long one. So you would have to find the mean, which we have, and then you would calculate this minus this, this minus this, on and on until you find all of the differences. You would square them, and then you would unsquare them. It's a long, too long to talk about here, but let's focus on getting the UCL formula. So the formula for the UCL and LCL, which you don't need for the exam, by the way. So let me bring this up here so you have a full idea of what exactly we're doing. Okay, so for the upper control limit, mean plus 3 standard deviations, right? 3 times SD, and the LCL is going to be your mean. For the lower control limit, we're going to do minus because we're going away from the mean towards 0, if you get what I mean. So it's mean minus 3 standard deviations. All right, now it's time for us to populate what the UCL and LCL will be. So let's go ahead and do the UCL first. The UCL is going to be the mean, this. So do equals mean, as you can see the formula up there, mean plus 3 standard deviations. So that's mean plus brackets 3 times standard deviation, whatever it is, close the brackets, hit enter. And that gives us 13.731. So this is pretty much the same thing all throughout. Let's see if it translates. It doesn't. So I'm just going to use values. Okay. It's going to be the same, exactly the same number. Okay. To give that straight line for the UCL. For the LCL, let's just take the formula, and instead of a plus, we're going to put a minus. We're going to put a minus there. So it's going to be, again, the mean plus, or minus, I beg your pardon, 3 times the standard deviation. That's how you get these numbers to get the lower control limit. And that would be that. Let's use values. And those pretty much are the values that we would use to create our control chart. I'll go in here and create like a time, the time of occurrence. And I'll just put in some random times here. Let's use the time format. All right, I really wanted to give you a clear picture of what exactly is happening. So if you take a close look, you can see these are times that each of these widgets was produced. See, that's your mean. That's your mean there as well. And that's the standard deviation that we used in the formula. Mean plus 3 times the standard deviation to get the UCL, the upper control limit, and mean minus 3 times the standard deviation to get the LCL. Okay. And when you're done with getting these, we can insert, let's select these, and we can insert a chart. So this one, that one, or a line. Yeah, more like this. Okay. So something more like this. And you can see it does need a little bit of formatting to, you know, really pop. But you can see this is the line showing you more like a run chart. The middle, the red one right there, is the mean. That is the lower control limit, and that is the upper control limit. And I could probably format it to show me the points. I wish I could see them bigger, but I'll have to go for an Excel course before I do this. It's been a while, you know, it's been a while I had to do these types of charts. Yeah, don't let me push my luck. But anyway, you get the idea, Cheat, and that's it. Okay, so taking a look at this chart, you can see that for the most part, apart from this point, that point right there, point 3, 1, 2, 3. Yeah, apart from the 11 is like the worst. That was cutting it close. But apart from that, you can see the process is for the most part in control. It would have been nice to see over a larger section of the population, maybe a larger sample. But I might do another one of these some other time to illustrate what exactly goes on in more detail. But that's it. Okay, let's see if I can label this. I bet you know how to use Excel better than I do. You would probably have been able to whip this into shape. Yeah, why don't you can play with the numbers, you know, after you get certified, and just take a look and have an example of your own, I guess. All right, so that's it for control charts. You see, it's a very long topic, and that's why it took a while for me to put this together. But I hope that now you're seeing it, it makes more sense. Just bear in mind that in the real world, the role of the quality manager will be a lot more extensive than this. There's a lot more involved, you know, when those folks are doing what they do. The role of the project manager is not to become the quality manager, okay? It's to assist the quality manager. All right? And that's it. Thank you and bye for now. I hope this helps, Cheaton. Let me know. Let me know in the comments below. Thanks. Talk to you soon.